Hello everyone, I'm Amio, and today I wanted to show you how I built this first-person cave level in Three.JS. So as you can see, this is running in the browser. This is a part of some work I've been doing for a while now in building my own sort of game engine that runs in the browser with Three.JS, and yeah, this is the latest level I've created for it. So as you can see here, it's a cave. We got stalactites, stalagmites. We got this sort of igneous looking rock texture which is all over the walls and the ceiling, and yeah, there's also some rumbly ambient music that I also made for this, and that is made in a different tool that I've created called web synth. It's all synthesized in real time in the browser as well, and I'll go over a little bit of how I made that as well. But yeah, I want to sort of go over the entire process that I used to create this from start to finish. So the first piece of that will be Blender. So I modeled the entire cave in Blender. This is the cave. It kind of looks like a big intestine or something like that. But yeah, it's semi-procedural. Most of the stuff in this engine that I'm working on is semi-procedural. So it's not like fully generated like a Minecraft world. It's more like I'll create something and then I'll use procedural aspects to add details or decorations to it and stuff like that. So I used Blender's geometry nodes to add for the procedural part. Without geometry nodes, this is how the cave looks. It would be very smooth and yeah, not a lot of texture or naturalness going on. With geometry nodes were used to deform it, make it look a little bit more realistic. So to create this tube, I used a path, or a curve rather, that Blender has. I used a Bezier curve. And with these, you can kind of extrude points manually. You can rotate them around. And I built out a cave segment using this to start with. And then Blender, I don't remember exactly how I did it. I looked it up online. You can turn your curve into a mesh and extrude it into like a hollow tube like this. And that's what I did. And I did a little bit of sculpting on it as well to add a little bit of width variations to different pieces. And this is what I was left with. And then to get the actual geometry nodes piece, let me turn that back on really quick. This is the setup I have here. So it's actually a little bit of stuff going on. Let me try to break it down. So you get the input mesh here, which is the base one that I kind of hand modeled. And then we have all of these nodes here, which is taking two different sources of noise, basically, which is randomness, and modifying it, transforming it, changing it around a little bit, doing some math on it to change the scale and whatnot, and then putting it into changing the positions of the vertices. So it's like it's a pretty common strategy people use to deform meshes procedurally. And then there's some other stuff here to scale it and just move things around, get the noise looking how I wanted it to, and then we just output the mesh at the end here. So when I export this, I export to GLTF format, which is a very common format in Blender. When you export it, you have to tick the option that says, where is it? Apply transforms or something like that. Mesh, apply modifiers. You got to make sure that's ticked. And that way it'll actually run the geometry nodes and export the output of it in your GLTF. And then I load the GLTF file in the browser in Three.JS, and I can, let me see. Get object by name. You can just have the cave as a Three.JS mesh, which you can manipulate, and I set a custom texture on it, and everything else like that. So speaking of custom texture, I wanted to show you how I made that. So let's go back to the cave real quick. Look at the walls. So yeah, when you spawn in, you fall down a tube. The previous level, let me make a little detour. The previous level is here, and you start. This is how you end it. I think I showed this level off in my previous video, how I made it. I'll have a link to the playlist somewhere around here in the description. But you jump down this tube, and then you get spawned into the cave level. So they're kind of connected. So that orange up there is actually fake. It's just a plane, and I have a spotlight added in Three.JS to shine down there and make it look like it's connected. But yeah, it's not actually part of the other level. But yeah, what was I talking about? Yeah, the texture. So you can see this rocky texture that's applied to the whole cave. Some notable things about it. So number one, there's no visible seams. If you're familiar with UV mapping in Blender or any other 3D modeling tool, UV mapping is how you take a 3D surface and you map a 2D texture onto it. And it's tricky to do it. Even if you have a seamless texture, it's tricky to do that in a way that doesn't have seams, especially in something like a big cave like this. So I initially did UV mapping manually. This isn't actually very good example. But like if you do a UV unwrap, it'll try its best to do it, but it gets really deformed. The texture looks horrible. So I had to use another solution here, which I will get into in just a bit. First, I want to talk about the image of the texture itself. So as I mentioned, it is a seamless texture, and I generated it like I do for a lot of my other textures in Stable Diffusion XL, which I have running locally on my computer here. So I generated this web UI. Here's the prompt I used. I have all this different settings that I've played around with to find something that works out well for me. And this was the image I got as an output. So yeah, it's seamless because I checked the little tiling checkbox there. But this is just an image. As you can see in the cave here, it's actually like responsive to light. It has those specular highlights. There's normal mapping as well. So it simulates a little depth that makes it look a whole lot better. It's very important to have that. So to achieve that, I used this tool called With Poly or Poly. And it is an AI-based tool. I pay $20 a month for the premium features, and it'll take your image, which is this, and it'll generate a bunch of PBR maps. Here's the normal map, the albedo map. I don't use the height map, but then there's like a roughness map and a metalness map as well. So that's what I used, and then I loaded into the I load the textures, the different maps, and then I stick them onto this Three.JS material. And then to get it to sort of look good on the cave, so there's no seams, I use a technique called Triplanar Mapping. So Triplanar Mapping is a pretty common technique for like procedural terrain and stuff like that, where you don't have the ability to manually create UVs. It works by looking at the normal or the angle of each triangle that makes up this mesh, and sampling the texture 3 times to pick the axis it's most closely aligned with, and then basically just tile infinitely on that axis. I'm not explaining it very well, but it's not actually a lot of code. I have 2 versions. This is all there really is. There's these 2 functions together implement it. So I wrote this custom shader, which is running in GLSL, and I added a little bit of extra pieces on top. So I have this contrast corrective sampling, which is a technique developed by, I think, Fabrice Niret. I found it in a shader toy. Yeah, here's the shader toy. It is a way to blend colors so you don't lose contrast. So this is on how it looks without it on the left and how it looks with it on the right. Definitely helps to avoid making things look washed out. Very useful technique. So we get our 3 samples, we mix them together based off of the angle of the triangle we're texturing for the fragment, and then yeah, we output the result. And then I do a little bit of sharpening. So instead of doing like a linear mix, I do like a sharper curve on the mix, which helps to also avoid making things look washed out or blurry. And honestly, it works really well. There are some areas you can see where you can see there's like transparency here, which doesn't look quite right, but there's actually not a lot of areas where it's pretty bad, and unless you're like staring right at it and looking for it, you don't notice it for the most part. There's some areas where it's a little artifacted, but I think it's very, very much acceptable. So yeah, that's the triplanar mapping, the procedural texture generation. I had a list of things I wanted to touch on here. the stalagmites and stalactites. So these are another semi-procedural piece. I modeled the base stalagmite in Blender, and then I sprinkled them into the cave procedurally, programmatically. So to do that, I took the Three.JS has a built-in mesh surface sampler, they call it, which I used and converted into Rust and removed some of the stuff I don't need from it. So this is just a way of like picking a random point on the surface of your mesh and having it like equally distributed. So it uses clever technique to do like what's the word? Binary search on like the size of the faces, and then it'll sample points and it'll give you coordinates. And it'll also give you the normal or the angle of the mesh surface at that point. So I translated it into Rust. As I said, took off some of the stuff I didn't need. Here's the binary search. And it returns a position and a normal every time you call it. And it is a seeded random number generation, so it's deterministic. All right, and then so that'll give me a bunch of points on the surface of the mesh for the cave that I can put stalactites or stalagmites on. However, I do some extra filtering, so I didn't want them just to be like completely randomly scattered, because it wouldn't look that good. I wanted there to be like some clumps, like areas where there's a lot of them, and then there's areas where there's not a lot of them. Where's my cave? There it is. So you can see like there's two here, and then there'll be the space with none of them, and then there's another. This isn't the best example, but there's some really dense areas where there's like a bunch of them that generate together, like here. And to do that, I use a noise function. So it's just a simple Perlin noise, and it is a way to treat the space. How do I explain this? It's a common technique, right? You generate your noise, and based off the value of the noise, if it's too small, we will just reject the point and try a new one. It's not the most efficient way in the world. There's probably a better way, but this code is written in Rust and compiled to WebAssembly with WebAssembly SIMD, so it runs very fast. So we can afford to be a little inefficient during this construction, especially since it's a one-time thing. This runs before the scene is initialized. That does not happen every frame. But yeah, we also do some filtering based off the normal. So I don't want like a stalagmite to generate just in a weird place. I make sure that they're either on the ceiling or on the ground, so we can use the normal. Just look at that to figure out whether or not to place it. And then I also use the normal to figure out whether to place it upside down, so it's a stalactite or a stalagmite pointed up. So yeah, this is something I'm this like mesh surface sampling stuff in Rust, as well as the noise function stuff. That stuff, it's really useful to have around. I'm going to be using it again almost certainly for other levels in the future. But yeah, I return all these positions, and then the scales. I think, yeah, I scale them a little bit as well, so they're different sizes, just random as well. And then I place them into the world. Here's all my stalactites and mites. Just a lot of pulling stuff out of the WebAssembly memory, and then constructing an instanced mesh in Three.JS, so they're rendered in one draw call very efficiently. So you can have a lot of stalactites and stalagmites without having to overwhelm your graphics stack with a lot of draw calls. So it's really works really well. I have a very strong GPU, 7900 XTX. It's kind of top of the line, but even then I have 165 FPS on the scene in 1440p monitor. So yeah, the performance is definitely good enough. What else should I talk about here? I think the only other thing I really want to touch on is the music. So as I mentioned, I built a tool, WebSynth, let me close some of these tabs I don't need anymore, to generate the music for the scene. So let me line up that audio really quick here, so we'll go over how that was made. All right, there's the music again. And so more nodes, right? Yeah, everything's nodes. There's a lot of nodes in this project. So we have some MIDI editor here, just different notes kind of randomly placed because it's kind of dissonant and atonal. Then we have this synthesizer, which is a frequency modulation synth, and some like envelopes controlling a filter, and we have this wave folder effect. And then, as you could probably hear, we have a delay, which is like an echo effect with feedback, so it'll come back through. We have this reverb, which adds a little bit more caviness and ambience to it, and that's it. It's a pretty simple patch. I didn't really want to build like a full song. This is kind of like a transition level, like a transition level between two of the bigger ones, which will have more fully featured music. But yeah, this web synth is embedded into the Three.JS world in a headless mode. So this whole graph here will still run just under the hood and output the sound. Oh yeah, there's a compressor as well. That's about it. A lot of fun stuff that went into this. I will be working on more levels. I already have started. You want a sneak peek? Sure. Working on another level here, so fun stuff going on here. I'll make a proper video on this once it's complete, but this is showing off a bunch of stuff I've been working on recently. So this big bridge, which looks like it's from Minecraft. It is from Minecraft. I took an old survival world I built in Minecraft and exported this model out to an OBJ file, which I converted into a GLTF file, and this is a Minecraft thing. And that fog is volumetric fog, which I built a shader for. Ray marching, very cool stuff. I love volumetric rendering. And the weird terrain is procedurally generated. It's a placeholder thing. And it is the way the colors correspond to the levels of detail. So it is a dynamic LOD terrain system. Very cool stuff. It's basically like allowing you to render procedurally generated terrain that looks high resolution close up and switches to lower resolution far away to save your resources when rendering. So still get 165 FPS here, but this is actually kind of pushing things. I got to optimize my volumetric fog shader. That's the worst. These are the most resources. I will show off this, as I mentioned in another video. I'm excited about this level. I got some big plans. Anyway, thanks for watching. I'm gonna keep making these as I develop new things, show off the ways I build these levels and develop this engine as time goes along. Hope you found it interesting, and if you have any questions, comments, leave them in the comments. I'll definitely check them out and reply. All right, thanks again for watching, and see you later.